Hello and welcome to The Road to Autonomy. I'm your host, Grayson Brulte. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to The Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to have Matt Soule, co-founder and CEO of Parallel Systems. Matt, welcome to the podcast.
Thank you, Grayson.
I'm excited to have you here because electric autonomous freight rail is the future. Electric autonomous freight rail will help decarbonize the planet. You're building the future, you're decarbonizing it. Prior to this, you had a 12-year run at SpaceX. What led you to start the company?
Great question. I mean, a place like SpaceX definitely keeps you challenged and on your toes, but Elon was about creating an insurance policy for humanity, allowing people to go to Mars if something was to happen to this planet. And I think as exciting as SpaceX is, it did start to feel a bit routine. Not that we conquered space travel or anything like that, but I started to become more interested in, what is my next opportunity, what's my next step, and grow interested in what can I do to make sure we don't need to move to Mars. And so kind of by accident, started to learn about the rail industry and became pretty enamored with what I saw in some of my co-founders as potential to uniquely help decarbonize freight. The energy efficiency of rail uniquely allows for reduction in energy and therefore reduction in CO2.
You went in a completely different industry, and you gave this really great quote to Bloomberg in September 22. I want to read to you about it. You said, "What we're doing is not in the space industry, so industry relationships, I had to create all those from scratch. But I think it's been one of the things that's most exciting, starting with a Rolodex with 0 people, and it's been really fun to build a network." When you first started having those conversations with the rail industry, it was like, what's the space gentleman doing here? Why is he here? What were those early conversations like?
Yeah, I think at my core, I just like building things. And in this case, it was just learning about an entirely unfamiliar industry and making connections and contacts to help me with that process. So when I started to read about rail and started to form some ideas and opinions about what might be done, I knew that this is an industry that economics matter. You're not going to sell a new service based on the virtues. You have to deliver at least as good as, if not better than, what all the alternatives are. So before we even started the company, I knew that we needed to get some feedback, some accounting for whether or not we were on the right path. And so I reached out. I remember I was catching a plane from Seattle to LA, and I reached out. Someone I just Googled, he came up in the top of the Google search result. And I talked to this intermodal economist and said, "Hey, I'd love to talk to you about this idea." And so by the time I landed in LA, he had already written back. And I think we talked on the phone the next day. And he validated a lot of our assumptions. And one of the things he pointed out to me was what you guys are likely overlooking is the importance of improving the quality of service. That is worth something. That has pricing power. But as he's talking about the industry, he made a comment "Oh, it's not rocket science." And there was kind of a pause. And I was like, well, I used to work at SpaceX. So I think that got him even more excited. But it was through this first person. It was Larry Gross. Larry introduced me to some other people and also got very excited about what we're trying to do and validate a lot of the problems we were after. And it was really from these first 3 or 4 people that started to build a network with industry. And the reception was surprisingly good. I mean, industry has not changed a lot. And to our excitement, there was a lot of positive feedback from them about what we're trying to do.
You're right about the industry hasn't changed a lot. If we go back to the days when Jay Gould was the owner of Union Pacific to where Union Pacific is today, not a lot has changed. When you spoke to economist Larry Gross, great job starting with an economist. You always have fascinating, long conversations with them. Did you see the ability to innovate? Because rail has a very prominent heritage, but it just seems that it really hasn't innovated outside of the work that's being done with electric trains and mines in Western Australia. But it just seems the overall freight industry has really not innovated much.
I think that's an accurate observation. And I think that, over time, a lot of industries become very comfortable with how things are done. I mean, the industry is very good at operations. They're very, very profitable compared to other modes of transportation. And so I think they've had a lot of success with that. And when you experience that success, it's understandable why no one thinks about why would we change this, right? This seems to be working so well. But a lot of the industry observers are noting that, okay, margins are kind of asymptoting. And so really for the industry to grow profits, you have to grow your revenue. And that's something that Rail hasn't really done in the last few years. And I'm talking about the US and North America specifically. But then you also have some things on the horizon that I think are going to challenge Rail's position in the world, which is self-driving trucks. And so I think the time is ripe really for them to start looking at, okay, this has worked really well for many, many decades. What is the next thing? What is the thing for us to grow and protect our role in surface transportation?
I see a future where a class one railroad buys an autonomous trucking company, merges in there, takes all the revenue in for the intermodal, and it quote unquote expands their railroad to a virtual railroad. The other way that I see for the railroads to do better revenue wise is network optimization. Can a system like Parallel help with the network optimization?
100%. I mean, the network is their most valuable asset. They own that right of way. They own the track that's on it. And so they want to drive as much business to it as they can. So what rail does today is generally serves for intermodal. They serve large volumes going long distances, and then all the other permutations of freight, lower volume, shorter distances goes to trucking. And so Parallel is developing a system that allows rail to expand their addressable market. So that's the most compelling thing about us, is that we're allowing them to expand their services and therefore the revenue. But what is unique about our system compared to legacy freight rail is this flexibility. And so this is an opportunity to fit this system alongside in and around these legacy operations. And so you can drive more business to that network. You can use like some of the unique smaller pits of track that would be difficult to serve these large scale operations they do today. So everything we're doing is about increasing revenue as well as helping to further optimize their capacity.
How are you doing it? How are you allowing them to expand their addressable market? Because what you described is you're a friend of the railroads.
That's what we're trying to do. So we think, just to be super clear, we're not trying to replace existing trains, because trains that are in operation today are generally very profitable. And so why change that? What we are doing, though, is we're looking at these other markets that, again, go to trucks, and we're trying to address what can rail do to be more competitive there. And so if you look at the architecture of rail, their operations, they require large scale to accomplish truck competitive unit economics. And when trains get shorter, yes, you're more nimble and flexible, you have better quality service, but trains get more expensive when they're shorter. And Parallel's platform is something that is working to accomplish truck competitive unit economics without requiring the massive scale. So our economics do not require amortization over large amounts of freight. I mean, that's what's happening on a train, right? You have a fairly expensive locomotive, the cost of operating it, and you're amortizing that locomotive expense over many, many units of freight. The problem now is you have this 3-mile long freight train. Where do you park a freight train that big? You park it in a giant terminal, which is also a very big expense to open and operate. And that's why rail doesn't generally do a great job of serving large volumes, is because you need that scale for it to be worthwhile and profitable for them. So our system, because we're focused on a single vehicle, let me take a moment to describe the vehicle here. We have a vehicle that is self-propelled. It has a battery, traction motor, it has sensors, radios, computing, all the electronics you need for control and autonomy in one unit. And so there are advantages for us to move together in small platoons, but they don't need to be at the scale that a legacy freight train would. And this is what allows us to serve lower volume markets. And because we can be smaller, our terminals don't need to be as big. And so we can get closer to the shipper and customer. And so your drayage costs go down. And the drayage costs are why rail usually doesn't compete very well with intermodal lanes that are less than 500 miles.
Would an example of a market be Port of LA, San Pedro, Long Beach to the Inland Empire? Would that be an example of a route that might work really well for this?
100%. I mean, there's a huge volume of trucks that leave the ports of LA and Long Beach every day to bring container volume to the Inland Empire. 10% of the warehouses in the US are in that location. And you have somewhere between 10 and 15,000 trucks a day that are making that journey. And so rail rail struggles, there are on-dock rail operations down there, but one of the biggest constraints at a port is the availability of real estate. And so legacy freight rail operations on a port, like you have competing demands for real estate. And so it's very hard to set up a conventional rail service at that port that can handle that volume. And so a system like Parallel, because we don't need to we need to accumulate container volume to fill a 3-mile long train, we can leave in smaller platoons. And so we can be a service that can bring containers from a port to an inland port where your shippers or your customers are, where your warehousing industrial activities are. And trucks likely could still play a role in that, bringing containers from that inland port a few miles and draying it to that final customer. But this is, again, like a good example of like shifting truck volume back to rail.
Could you go as small as one container if it was medical or something that had to get there? Or what is the ideal amount of containers for you to move at any given time?
We can go down as low as one. That is not, we think, for the most part, the right way to operate it, though, because using a single vehicle can tie up network capacity, and it's also not the most energy efficient. The way our system works is we have a platoon that we form, and there's a bumper between each vehicle. And so we push from the rear. We share work mechanically through that platoon by pushing from the rear, and there's a bumper that allows those forces to be transmitted from the rear to the front. And so when we're in a platoon, we're amortizing the drag that lead container experiences over all those cars. And so when you get to about 10 cars, your energy advantages of the architecture kind of asymptote. So 10 is kind of the minimum that we look at for energy efficiency reasons. But we can maybe last mile or unique use case, like we could go as low as one. But the other thing you compromise, though, is network capacity. And so we've been doing a lot of operational models with industry, and we show that platoons ranging between 20 and 30 cars really gives a great balance between flexibility, quality of service, and network capacity. But what we're developing, though, is the capability to go up to 50 cars in a platoon. And what sets that upper limit is, well, we have to set an upper limit because the dynamics between the bumpers get more complex the more cars you have connected together through this bumper interface. And from the business perspective, we've looked at this, and our conclusion is that even the highest volume lanes, trucking lanes out there, multiple 50-car platoons a day, we think can serve the vast majority of the freight in these lanes. And so there's not really a need to go higher than 50. Otherwise, we're kind of just looking at a conventional train. And then that sets a limit on the engineering targets for the bumper system.
My wife grew up in the Midwest, and there's times where we're going to the grocery store or going somewhere, I've had to wait a half hour as this long freight train goes by, and I'm tapping my foot. Okay, come on. And it keeps going and going. It's like, it's the old kid saying, are we there yet? Are we there yet? Train, are you done yet? Are you done yet? How will your system interact in a scenario such as that? Will it be a very polite train that says, oh, let's stop. We're going to have 10 cars go through, and we're going to hold the other 10 until these nice motors go through. How will your system interact with that scenario?
Yeah, so I mean, the case for the bumper, not having a coupler, we don't have a conventional coupler. Like a coupler is that knuckle, right, that would allow a locomotive to pull or push rail cars. So that coupler provides the ability to have tensile or compressive forces. We're just strictly making a contact bumper system. And so it is both inexpensive, and it gives us that flexibility to basically software define platoon sizes. So a case like you brought up is we can have our platoon stop and split to allow passenger traffic to go through a grade crossing. There's a lot of reasons why, the experience you just shared might be happening. It might be because that train is trying to crawl into a terminal, and there's a very slow process of cutting up the train to fit the pieces of train into the terminal. And so because we're self-propelled and autonomous, even at a large size platoon, we can more quickly split up and slide into a terminal. So there's a lot of reasons why we would not create the congestion you see around a grade crossing you just described. We're smaller, we're faster, we're able to keep moving. We can split up the platoon and keep those grade crossings open.
You're the polite train company. I repeat, you're the polite train company. Is that the new slogan for the company?
It's a good thing for us to think about.
I like this. And then after the passengers go and the cross guards go down, does the platoon reconnect again at a later point, or does it continue to operate independently?
It would really depend on the network planning. Very likely, if they're close together, is a good case for them to reconnect. But if the capacity is there or they're headed to different destinations anyways, it might make more sense to keep them separate.
From the autonomy aspect, how's the system operating? Because it sounds pretty advanced from what you described already with the cross scenario.
Right. Well, there's a core principle to Rail that we're not changing. And that is that you do not go onto the network without having some authority to be there. This concept of track authority. This is how trains avoid collision. And this has been, there's various different ways to do this, but there's this key concept of you don't give track authority to more than one train. So what we are doing is completely compatible with that way of operating the network. We're not randomly wandering the network and like wreaking havoc on existing operations. We are planned activity, and we coordinate with that central dispatch and train control office. And so our system is basically going to it's going to have a mission, and it's going to ask for permission to enter the network, and it's going to be granted by a dispatcher, just like a normal train would. And when we say we're autonomous within that track authority that we've been granted. We're looking for the condition of the rail. We're looking at whether or not it's safe to proceed down the track in front of us. And so we could be looking at grade crossings. We could be looking for trespassers. We could be looking at the condition of the rail itself.
The United States has 140,000 miles of freight rail track. Are those the tracks that you're going to operate on?
Right. Our system is designed to be compatible with that existing infrastructure. We're not proposing to build new infrastructure. We think there's a tremendous amount of track that is, by many measures, underutilized. And so this is taking advantage of that excess capacity and driving new business to rail that can leverage the existing infrastructure.
Do you see the track owners putting restrictions on parallel in terms of when you can and cannot operate, or perhaps somebody gets squirrely? Oh, you're a competitive threat. No. We're going to slow walk this.
Our model here in the US is not to be an operator, but to be a vendor to existing operators. So we're more like an OEM that is creating a set of tools to enable these existing operators to market and operate these new services. So any restrictions in place would be through their own internal planning around the services that they want to put there. Very likely in the early days, their legacy operations are going to take priority, but the design, the intention is not to compete and cannibalize those services. It's to augment what they already do and again, capture new volume. And it can even be related to what they already do. It's like these intermodal services that are in place today. Our system can be a feeder network into those legacy terminals. We can shift these long drays that happen in many places in the country to a platform like ours. Then we show up in the terminal and we still get lifted off of our platform onto a legacy freight train, just like a truck would.
Do the terminals have to be upgraded when one of your customers purchases your system? Do they have to upgrade their terminals? They have to put in electrical infrastructure to charge them? Any physical changes they have to make in order for parallel to operate properly?
Primarily just in the sense of providing charging capabilities. Our concept for charging is that because you had to fundamentally dwell to unload and load, we want to take advantage of that dwell time to also charge the vehicle. So what we are working toward is identifying a dedicated track for our platoons to arrive. And there are charging nests that are embedded in the tracks below. And so you're pulling up basically this charging docking station. And we make contact with it. We're sitting there for a couple hours charging our batteries. But while we're doing that, the equipment is being unloaded and loaded with new equipment. And so we've looked at, based on the size of our platoons, we think the charging infrastructure would probably be somewhere between 3 and 10 megawatts. And I think that's one of the advantages of this architecture, is that because rail is energy efficient, it also means that, not only do you not need as big of a battery, but you don't need as powerful as a charger to have similar charge rates. A truck that have about 500 miles of range, electric truck, is going to need about a megawatt hour battery. And for our vehicles to have about 500 miles of range, we need about 250 kilowatt hours of battery. And so for a 1E charge rate, we need a 250 kilowatt charger versus a megawatt charger. That's less expensive charging infrastructure. And because it's a captive network, you can also be more predictive about the utilization of that charging infrastructure. So there's a lot of economic advantages to charging on a rail network, because charging equipment is cheaper, but you're also could be more certain of how many hours a day you use it, which is equally important to the cost of it.
And here's this is inside baseball. rail yards have a lot of electricity already coming in, so you're not going to have to run big conduit lines. So bravo on that move.
Yeah, and we think it could be a complement to trucking too. Like electric trucks are coming and it's absolutely the right thing to do. But it is challenging to think about how are these going to be charged. And terminals could be the node where both rail and trucks are charging their batteries. And if trucks can focus more on drayage, there's not as much pressure on trucks to do long haul. Electric trucks get easier when you're focused on drayage. You don't need a 500-mile range truck. You need a 150-mile range truck. And when they come to the terminal to pick up freight or park overnight, that can be where they recharge as well.
And that creates efficiencies and lowers carbon emissions. And it's a win-win all around. You mentioned earlier that the rail track is underutilized. I'm really curious. Can you put numbers to that of how underutilized the freight rail track is in the United States?
It varies depending on where you are. There are a lot of sections of the network that are arguably being used at their capacity right now. And there are technologies on the horizon that will allow that capacity to go higher. But on average, the utilization is about 3%. So of that 140,000 mile network, about 3% of that network is going to be occupied by physical train at any given time. But it is an average and it does vary. Part of that capacity is limited by the track circuits that are in place right now. But a lot of the rail industry, even without us being on the radar, are looking at moving blocks where there's no longer a physical bound to how big that section of track is that a train can be in. The block, which is like a safety keep out area, follows the train. And so that allows them to increase density on that line. The other thing that is probably not intuitive to a lot of people, but because of the nature of the network, the time in which you enter the network also has a lot of influence over the capacity, because when trains meet at a point in the network, they have to be able to pass each other. And so when you have these meet pass points, it all works if everyone is entering the network on time and traveling at the predicted velocity, because you're meeting in the expected place and then you can pass the other train. But there's only, finite places in many sections of the network where you can pass each other. And so if a train is late, then the other train is coming the other way, has to wait for that train to come so that they can pass each other, because there's only that spot to do it. And so when you have a platform like ours that can be very time scheduled and enter the network at a predictable time interval, there's an opportunity to increase network capacity through that as well, right? Because you're being more predictive about when you meet other platoons or trains.
And that leads to increased revenue and profit margins. I'm getting fascinated when you mentioned network. I keep thinking, is this a air traffic control center for the United States where an individual approves, okay, train A, you can go in now. Train B, wait. How does the network operate?
So the railroads are privately managing these networks, and they have their own dispatch centers that are controlling these. They have a lot of signaling systems that don't require a dispatcher to be on a radio with an engineer. The dispatch center is, through the track signaling systems to the engineers, is allowing trains to safely progress through the network. There's a system that has been recently deployed called positive train control, which is supervising these activities. They're making sure that the operators are heeding the signals, they're paying attention to speed limits, they're keeping safe speeds and keeping away from where maintenance is happening on the track. But this is positive train control is a big part of helping to enforce safe operation of these networks. But it's not something that's managed at the federal level. Each railroad is managing their own operation for how trains are able to move through the network.
Thank you for shedding that light on the freight trains traditionally take a very long time to come to a stop, how long they are. When I'm doing research, since braking is one of your key technological breakthroughs, could you talk about how you developed your braking system, please?
Yeah, this is related to developing our perception system too, because we're looking at developing a system that we think can be as safe as possible. And so it's both about perceiving the conditions of the track in front of us, but also being able to respond to what we observe as fast as possible. And so legacy freight trains in the US use air brakes. It's a legacy system. It's been around for a long, long time. It's very well understood by industry, but it does leave opportunity for stopping faster. You have generally pretty high latency of that drop in air pressure propagating to the end of the train, and then you don't have control over the stopping force depending on how heavily loaded each rail car is. So what Parallel is doing is developing a braking system that does close the loop, and we're able to dynamically change our braking force depending on the track conditions, the adhesion of the train wheel to the track, as well as how heavily we're loaded. And so we're trying to stop as fast as physics will allow us. And so when we're able to do that, then it relieves some of the requirements on our perception system. So now we're in a place where having a few hundred meters of perception is able to see beyond that stopping distance. So we're actually able to react to things much faster than a legacy freight train would be able to.
You're creating safer rail. You're creating safer rail from a perception standpoint. There's rocks on the track. Sometimes there's a bag or a bottle might pop up. Did you have to harden your perception system to deal with everyday life out on the freight rails?
Yeah, there's certainly a lot of training to do to recognize what are the things we should stop for, what are the things that are not a hazard. And that's always going to be an ongoing process, but it's something we're working at right now.
You're catching a lot of people's eyes. One of those eyes you caught was the U.S. Department of Energy. You recently won a grant, $4.4 million, which will allow you to fund a 29-month advanced testing program with the goal of demonstrating overall vehicle stability, contact-based platooning, and energy efficiency. And I want to highlight on the energy efficiency that your battery electric rail vehicles use just 25% of the energy of a semi-truck. You're creating really good efficiencies. Could you talk about the grant and how you got on the DOE's radar?
Sure. I mean, it's really awesome to be working with the RPE office on this and have their support. And we're also really excited to be working with Railtech, which is part of University of Illinois, as well as NREL and MXV Rail, which is part of the AAR, and they have a testing center in Pueblo, Colorado. So what we're doing, though, is we are modeling the operations of our concept. And so this is to quantify the service benefit, the nature of the operations, but then working with NREL, quantify the environmental impact and energy impact of something like this. And then what we're doing with MXV Rail is we are developing dynamic models of how our vehicle handles on real world track. And then we're going to be doing testing to validate that those models accurately predict our dynamic performance. And this is about safety. This is about having confidence that we're going to stay on the tracks.
The environmental impact is interesting. Will the DOE make that data public around the positive environmental impact that your system has?
Yes.
Beautiful. I want to say you're doing great things. I'm a fan of Parallel. I like what you're doing. You're building the future of rail. When the grant concludes, will you go all in on commercialization, or are you doing that in parallel?
Yeah, I think we're always working toward that goal. I mean, what we have to do right now is continue to develop and test our vehicles and really understand our product market fit. And the testing we're doing right now is to really help inform that understanding and give us the feedback to go into what will be our third generation vehicle, which we think is the vehicle that we would put forward as our effort to commercialize. So we're on our second generation vehicle right now, and this is what we're doing testing with, but we have committed to doing a third generation that would incorporate what we learn in the testing we're doing.
1 to 3. I'm going to use the SpaceX analogy. You're going like a rocket ship. It seems that you're constantly making a new product. What was the timeline on from Gen 1 to Gen 3?
Well, we haven't done Gen 3 yet, but we went about, it's been about a 2-year cycle between generations. When we started the company, we had our Gen 1 vehicle. I mean, it was a very scrappy prototype. We had our Gen 1 vehicle on test tracks within about 9 months of founding the company, which is pretty fast. But I think, some of the features of that vehicle were consistent with how fast we did it. We learned a lot from that experience. And that was one of the purposes of it, is we both wanted to develop a test bed for doing testing and understanding how can we make this better, but also to show people in industry how this would work, because it's obviously very different. And I think it's often very important to have a forum for people to come experience how it's going to operate. So it was about 2 years. It was almost exactly 2 years since we put that first gen vehicle on the tracks that we have now put our second gen on the tracks. And we're just starting to do the much more in-depth testing program right now. Hard to say exactly when Gen 3 will be out there testing, but that's been what we've done to date.
What you've done to date is you've shown, you've not told. You're delivering, similar to SpaceX, you're delivering product. You're doing really good. Your future is extremely bright. Parallel will play a large role in the future of freight. Outside of Parallel and the future of freight, what is your opinion on the future of freight?
There's a lot changing right now, which I think is all fantastic. I mean, what Parallel is doing is really developing a different vehicle and service that is going to offer more capacity. I think there's a lot of great efforts underway to improve the integration of freight activities, which I think is arguably one of the biggest opportunities. And we intend to play a role in that too. But Parallel's creating capacity for freight. And so I think faster service, less expensive service, but also reducing the CO2 footprint are all things that Parallel and others are trying to do.
And that's what I'll use a baseball term, a home run, or you can use the term a win-win. Matt, I thank you for coming on the Road to Autonomy today. You shed so much incredible light on the future of rail, what Parallel's doing to create capacity for freight, what you're doing to decarbonize the planet. And as a takeaway, what would you like our listeners to take away with them today?
What Parallel is doing is enabling modal shift. We're not trying to replace freight trains. We're not trying to replace trucks. We're trying to shift more miles to rail. And that is an opportunity to decarbonize freight as well as an opportunity to decongest freight activities around cities and ports.
Parallel is decarbonizing freight because the future is bright, the future is autonomous, and the future is parallel systems. Matt, thank you so much for coming on the Road to Autonomy today.
Thank you, Grayson. Thank you for having me.
Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter at Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed on this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.